You walk into a room you know extremely well. Maybe it's your bedroom. Maybe it is the living room you pass through every morning. You have entered it so many times that you no longer consciously examine it. The lamp is beside the table. The books are still on the shelf. The curtains are moving slightly near the window. Nothing is missing, nothing is broken, nothing appears obviously unfamiliar. And yet, before you can explain why you stop, something feels wrong. You look at the lamp. No. You check the window. There's nothing there. You scan the bookshelf, the table, the floor, and the shadows in the corner. Everything seems ordinary, but the feeling remains. It's almost as though one part of your mind has noticed something and has forgotten to tell the rest of you what it noticed. So, what is happening? We often imagine vision as a camera. Light enters our eyes, the brain receives the picture, we see the room exactly as it exists. But human vision is not a continuous, perfectly detailed recording. A familiar room contains thousands of pieces of visual information like colors, edges, distances, shadows, textures, reflections, objects, and relationships between them. If the brain had to carefully reconstruct and consciously examine every one of those details each time you enter the room, even the most familiar place would constantly demand your full attention. Instead, familiarity gives the brain something extremely useful: expectations. The lamp should be beside the table. The shelf should be against the wall. The window should be above the desk. The chair should face the desk. These expectations help the visual system interpret what it is receiving. It does not necessarily mean that the three-dimensional copy of your room is stored inside your head. In fact, our visual memory is far less complete than it feels. Try to picture your bedroom right now. You can probably imagine its general shape. You may know where the bed, window, and bookshelf is, but you might also remember the color of the walls, but can you remember the exact angle of every object? How many books are visible? Which direction is every handle pointing? Where does each cable touch the floor? What precise shapes do the shadows create? Probably not. Your memory contains enough information for the room to feel familiar without preserving every detail with photographic precision. It may remember relationships better than measurement. The chair belongs near the desk. The lamp belongs beside the table. The books belong on the shelf. This produces something like a structural understanding of the room, not a photograph, but a map of what normally belongs where. And perception may use that prior knowledge. Research into predictive processing suggests that perception is influenced not only by information entering through our senses but also by expectations formed from context and previous experiences. In simple terms, the brain does not always wait passively for the world to explain itself. It makes informed guesses. So, when you enter a kitchen, you expect certain kinds of objects. When you walk towards a staircase, your body anticipates the height of the next step. When you reach for a familiar light switch in darkness, your hand moves towards a location it expects to find. Usually, the incoming information agrees with the prediction. The step is where you expect. The switch is where your hand anticipated. The familiar room still resembles the internal model created through previous visits. When expectations and reality agree, there may be little reason to direct conscious attention towards the difference, because there is no important difference. Everything is where it's expected to be. But tonight the chair is not facing the desk. Someone has turned it slightly towards the door. It has not disappeared. It has not changed color. It may only be sitting at a different angle. You could look directly into the room without immediately identifying it. Your attention is selective. It cannot give equal priority to everything at once. Perhaps you first look towards the window because it is moving. Perhaps the lamp captures your attention because it is the brightest object. Perhaps you inspect the doorway because the uneasy feeling makes you wonder whether someone entered. Meanwhile, the chair remains visible without becoming the object of conscious focus. There is another complication. Even when we remember the scene clearly, memory can preserve some features while weakening or altering others. We may remember which objects were present but become less precise about their exact possessions. So, the feeling is not produced by comparing two different photographs. It may emerge from a much messier process, current sensory information interacting with incomplete memory, learned structure, attention, and expectation. Most of the room still matches, but not all of it. The overall arrangement is close enough to remain familiar, yet different enough to create uncertainty. Within predictive processing theories, a difference between expected and incoming information can be described as a prediction error. That phrase sounds dramatic, but an error here does not necessarily mean that something has malfunctioned. It means that the prediction and the sensory information do not completely agree. The system now has several possibilities. It can update the internal model. Perhaps that is simply where the chair belongs now. It can seek more information by directing attention towards the room, or it can treat the difference as unimportant noise. But before the mismatch is resolved, you may experience uncertainty without processing a clear explanation for it. First comes the pause, then the searching eyes, then the feeling that something is wrong, and only afterwards the chair. The strange thing is that the reaction may begin before you can put the cause into words. Your eyes move around the room, your head turns, your body becomes slightly more alert. Conscious recognition arrives later, carrying a tidy explanation. Oh, someone moved the chair. But the explanation should not be confused with the beginning of the process. By the time you can name the change, your attention may already have been searching for it. This does not mean that every uneasy feeling is a supernatural warning. It does not mean that the brain always detects hidden changes correctly. Sometimes the room feels different because the lighting changed. A passing car may cast an unfamiliar shadow. A curtain may alter the room's balance by moving. The air conditioner may stop, removing a background sound you normally ignore. You may be tired, anxious, or distracted, and sometimes your memory is simply wrong. You might become completely convinced that an object has moved even though it has been in the same place for days. Expectation can help perception, but expectation can also mislead it. This is what makes experience so interesting. The brain must interpret the present using a past that was never recorded perfectly. It uses incomplete memories to form expectations, then uses new sensory information to correct them. Most of the time, this happens so smoothly that we experience only the final result. A stable, ordinary room. You turn the chair back to its desk, the mismatch disappears. The room feels ordinary again, not because there is a universal law saying that the chair must feel the desk, and not because the room itself has one objectively correct arrangement. It feels right because what you were seeing once agrees with years of repetition taught you to expect. But imagine leaving the chair where it was. At first, it may continue to attract your attention. Tomorrow, it may still look unusual. After a week, however, the new position could become familiar. The internal model changes, the prediction adjusts. What once felt wrong becomes the new normal, and that reveals something slightly unsettling about familiarity. A familiar place may not feel familiar because we consciously remember every part of it. It may feel familiar because reality is producing very few surprises. The room becomes almost invisible not because you cannot see it, but because you rarely need to question it. Until one chair turns, one shadow disappears, one quiet background sound stops, and suddenly an ordinary room becomes a problem your mind has already started solving before you know there is a problem. So the next time you enter a familiar place and inexplicably stop, look carefully. Maybe something changed, maybe nothing changed, and your expectations did. Either way, the feeling leaves us with a much stranger question: how much do you notice before you know you noticed it?